Marine accidents always endanger human lives. In designing ships, the first principle is safety first. The engine and the power transmission mechanism, the heart of the vessel, must operate with maximum safety for the crew throughout the 20-year lifespan of the vessel. Gears have long been employed exclusively for power transmission in ships. In the shipbuilding industry, only the courageous builder dares to design the unconventional, and only the pioneering owner dares to accept it. The engine designer of Japan's leading shipbuilder, which first adopted roller chains, said this: "By replacing gears with roller chains, we can achieve more economy and more freedom in design, because power can be transmitted to the shaft wherever it may be located." But since the roller chain itself is a complex mechanism, it sometimes resonates and vibrates in unexpected places. Seizure sometimes occurs at the pin or the bushing. Sometimes the link plate or the roller breaks. So we face complex problems in maintenance. The designer continued, "Both roller chain and gears have their merits and demerits, and it's hard to say which is better. But we designers are confident that the roller chain is definitely more advantageous. In the early days when we began using it, however, we faced a number of difficulties." We had to settle such problems as quality requirements for the link plate, for heat treatment, the clearance between the pin, the bushing and the roller, lubrication, and many others. We settled these questions one by one until we completed the marine engine mechanisms we are now using. The chain drive mechanism is being adopted for more and more machines needed in modern times. Machine designers are applying chain drive to high-power, high-speed drives hitherto considered impossible for roller chains. How to meet still heavier loads and still higher speeds confronts roller chain designers. The roller chain's ability to transmit power as accurately as gears to rotary shafts at long distances is inspiring its continuous development. Have not found such action a problem. The engagement of the chain and the sprocket is effected in a circular arc. This indicates that the contact pressure is extremely light compared with the engagement of 2 gears. Moreover, the load on each tooth is quite small, since the rollers engage about half of the sprocket teeth. The endurance of sprocket teeth is therefore far higher than that of gear teeth. Theoretical analysis of chain drive operation is also in progress. As the chain speed and load increase, that part of the chain engaged with the sprocket is swollen. If there is too much slack, the chain sometimes pulsates. Thus, a tensioner to normalize the motion of the chain is required. Experiments are conducted to devise ideal tensioners. Tensioners made of oil-resistant synthetic rubber are generally employed. For high-speed revolution, oil pressure tensioners are most helpful. But for medium-speed revolution, spring tensioners are commonly used. If the pressure of the spring is too heavy, the durability of the chain is affected. Resonance of the frequencies peculiar to the chain and the spring must be eliminated. When employed for a large-sized chain reducer, the slack is eliminated with a lever tensioner. Sometimes an idler serves as a tensioner, depending on the arrangement of the shaft and the reduction ratio. The tensioner is usually attached to the slack side, but sometimes it is fixed to the tension side. This serves as a shock absorber when the chain is overloaded. The tensioner engages the chain and the sprocket more precisely and prolongs the life of the chain drive. When torque variation occurs, the chain sometimes begins to vibrate. The natural frequency of the chain varies according to its type, length, and tension. In order to prevent vibration, a damper is used. A good result is obtained if a slight opening is left between the damper and the chain. If the damper is too short, it is likely to begin split vibration. Sometimes it is necessary to attach both a tensioner and a damper. The system of lubrication requires special designing. The durability of the chain depends on lubrication. No wear occurs if it is perfectly lubricated. Wear is accelerated if lubrication is unsatisfactory. To ensure long life of the chain, lubrication methods must match the various speeds of revolution. Needless to say, the higher the speed, the more oil is needed. Some believe that chain drive is vulnerable in high-speed operation, but this is no longer true. Timing chains are in popular use for automobile camshaft drives with revolutions of 7,000 per minute. A designer of the leading Japanese automobile company using the timing chain has this to say: "We can ensure absolute strength of the drive because the roller chain meshes with a number of teeth, whereas gears engage only 1 or 2 teeth. It doesn't matter if the drive is somewhat noisy, so long as it is strong. On long-distance runs, one must count on safety more than anything else. We certainly appreciate the great strength afforded by the chain drive. Selecting the position of the shaft is important to maximize the absorption efficiency and high-speed revolution of the engine." The roller chain drive gives us greater freedom in fixing the shaft in the most appropriate position. because the revolution ratio of gears is only 1 versus 2, they must take up large surface area. If this is to be avoided, we must insert idle gears, which means higher cost and more chances of mishaps. How about noise? Well, at first we were prejudiced against the roller chain, but we found after putting it to actual use that we were wrong. We can further reduce the noise by developing better tensioners. The designer continues, with the compact chain drive, we can radically reduce the thickness and still maintain the same strength. Bakelite gears of the same strength require thickness nearly twice that of the chain drive. We are, of course, anxious to make the engine as small and as compact as possible. The chain drive certainly answers the demand for compact and powerful engines.